solve another Leetcode problem. 3152 Spencer array 2. So this is from the Leetcode weekly contest. So we are giving an array nums, and it has just even and odd numbers. And we have such queries, and we want to query. So for example, query from 0 to 4, this means from index 0 to 4, we just want to check if it is a Spencer array. So the Spencer array is defined as from index I to index j. So all the numbers like even odd or odd even, it's gonna be like that. Yeah, now let's try to solve the problem. So the length of the nums is 10 to the power of 5. Yeah, and the query is also 10 to the power of 5. This means we cannot solve it in O(n) square. We have to solve it in less than O(n) square, maybe n log n time. Yeah, let's try to check if we can solve it in n log n time. Let's just use this example. So if we have an array like this, now for 3, 4, 1, 2, so inside of the subarray from index 0 to 3, so we are sure it must be valid. Yeah, so if the query is just inside, I mean in between 0 to 3, so it must be true. And then we have another one, it's gonna be from index 4 to 4. Yeah, so basically we're gonna split the array into different indexes, and between all those indexes it should always be valid. So for example, index 0 to 3 it is valid. So for from here 0 to 3 it is valid, but for this index 4, 3 and 4 is not valid. Yeah, but from index 4 to 4 it must be valid because there's only one number. Yeah, so first of all we're gonna split the array into the valid subarray, and secondly we just need to use a binary search to check. So for example, for the query, if it is 0 to 4, so what's gonna happen? So first of all, we're gonna use this 0 to check, to use a bisect right to check which position it is. So for this 0, 4, the position is index 0 because bisect, the position is index 1 because while we are using the bisect right, so the index should be 1. And then we're gonna check the previous value. So the previous value is index maybe currently it is I, and its previous value is index I minus 1, and then we're going to check this number 3. So if this 4 is more than this number 3, definitely it is false. So if this number is less than and equal to this number 3, so we're going to return a true. Yeah. So let's just try to solve the problem. We're going to prepare a result array. So for this result array, I will put 0 to 3 and 4 and 4 inside. So this means all the subarrays must be valid. And I'm gonna prepare I and n. So I should be equal to 0 and n should be length of the nums. Now I'm gonna use a list group to put all the range inside the result, like the 0, 3 or 4 to 4 inside of the result. So while I less than n, j equal to I, and while j less than n, and yeah, so we have to check two ways. So if yeah, so the j should be equal to I plus 1, so we need to check the next. So for example, currently it is 3, so we're gonna check the next. So we're gonna check if my current number, so for example, if my current number nums j, if nums j modulo 2 equals to 1. So if my current number is odd, so the previous number must be, yeah, so the previous number nums j minus 1, so must be even, must be 0. Or we can check another one. Yeah, or there's another case. We can just change it, copy it. Yeah. So or if the previous one is the current one is even and the previous one is odd. So if we meet either of the cases, so it must be even odd or odd even. So what are we gonna do? So j should plus equal to 1, and the result array should append the result. So it's gonna be yeah, we're gonna append an array. It's gonna be I to j minus 1. Yeah, because if it didn't meet the case, the j would plus 1. So here should be j minus 1. And finally, so I should be updated to j. And now we're gonna check what is inside the result array. Let's just check if it is okay or not. Yeah, we just need to check what is inside the result array. It seems it is wrong. It should be 0 to 3 and 4 to 4. Let me check. Yeah, if nums j modular 2 equals to 1, yeah, I forgot to modular 2. It should also modular 2, and here also modular 2. Yeah, it should be like this. Now I would to run it to check. Yeah, as you can see, it is from 0 to 3 and 4 to 4. It seems the split of the array is okay by using the list groups. I would to set the code editor, maybe word wrap. Yeah, maybe this is better. So yeah, so now the second step is just use the binary search to get the final result. Yeah, so we're gonna prepare m should be equal to the, or we're gonna prepare an answer should be equal to false times length of the queries, and then we're gonna check the queries. So for a, b, let's use enumerate. So for I, a, b, in enumerate the queries. Yeah, so we're going to use the bisect right as I explained earlier. So j should be equal to bisect. We're going to use the bisect right with the result, and the current number it is a, and we need to use a lambda function because this result is not a 1D array. It is a nested 2D array. So it's going to be lambda with x to x0 because we're going to compare the first index. Now for this j, so for example, we get a result array 0, 3, 4, and 4, and our j, for example, we're going to check 0. So the bisect right, why we are using bisect right for this j, the j should be equal to 1. Yeah, but we need to check j minus 1 inside the result array. Yeah, so result j minus 1, it should be 1. So we need to check if this number, if b, so if b, currently it is 4, but if b is less than and equal to this number, it means the answers I should set to true. Otherwise it is false. Now we can return the answer. Yeah. So the time complexity would be n log n, because here we use the binary search, here we use the bisect right. Yeah. And here is just a for loop, and this is O(n) because this is just a list group. Yeah. Now let me try to run it to check if it works. Yeah, as you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases, and it seems pretty fast. I don't know, maybe, yeah, just submitted earlier because I didn't submit this question from here before. Yeah, so that's it. I think that is most of the questions. If there's queries, maybe we can use binary search to check if we can do it by n log n time to let it pass for this kind of testing cases. Thank you for watching. See you next time.